Good morning, students. As you all know, yesterday we covered topic colloidal solution. Now here is a table of types of colloidal solution. Then when there is a different phase and the different medium, then what type of colloidal solution is formed and what are their examples. So the very first is here the dispersed phase is liquid and the dispersing medium is gas. It means when liquid is dispersed in gas, the type of aerosol which is formed is aerosol, and the example is fog, cloud and mist. Similarly, the best example if I am giving you here is milk, in which the dispersed phase and the dispersing medium both are liquids. And the type of colloidal solution which is formed here is emulsion. It means here liquid is dispersed in liquid and milk is an example of emulsion. Moving to the next, here are the type of solutions. It means as we already studied there are three type of solutions, which is true solution, suspensions and the colloidal solution. The true solutions are those in which the particles are of very tiny size, which are about or less than 10 raised to the power minus 9 meter, whereas the particle size in suspension is much greater than 10 raised to the power minus 7 meter, whereas the colloidal solution particles are the intermediate between the true solutions and the suspensions particle. Like the size of the particles of colloidal solution is ranging between 10 raised to the power minus 9 meter to 10 raised to the power minus 7 meter. Now moving to the next topic, which is Brownian movement. As we all know that there are the particles present in the solution. If I am taking the example of colloidal solution, then there are the colloidal particles which are in the solution, and the zigzag motion or the random motion of the colloidal particle in the solution is known as the Brownian movement. It means the colloidal particles are moving at random in zigzag motion in all direction, that is known as Brownian movement. It means the zigzag motion of colloidal particles which is present in the solution, they are randomly freely move in all the direction, that is known as Brownian movement. Brownian movement is caused by the collision of the colloidal particle with the molecules of the dispersion medium. It means the molecules of dispersion medium and the colloidal particle, they both collides with each other, due to which their velocities will change, their motion will change, the direction of motion will change. That's why these particles moved in a zigzag random way in a solution, which is known as Brownian movement. The very next topic is Tyndall effect. The very first time this phenomenon was studied by the Tyndall, therefore it is termed as Tyndall effect. This effect is due to the scattering of light by the colloidal particle. It means if we strike a beam of light on a colloidal solution, the scattering of light is happened due to the presence of colloidal particle in it. The particles in the true solution are too small in size. It means the particles in true solution are too very small, due to which there is nothing kind of scattering of light in true solution and there is no Tyndall effect observed in true solutions. The definition of Tyndall effect is the phenomenon of scattering of light by colloidal particles as a result of which the path of beam becomes visible is called Tyndall effect. It means that phenomena due to which if we strike a beam of light on the colloidal solution, due to the colloidal particles, the beam of light is scattered in the direction and due to which the path of beam is visible in the solution. That is known as the Tyndall effect. In the first figure, we can see that there is a true solution in which the size of the particles is very small, and due to the small particle there is no scattering of light in it. That's why the path is invisible in the true solution, whereas in the colloidal solution, due to the motion of the colloidal particle, the light collides and is scattered with them, due to which the path become visible in the colloidal solution. Here is an example of the two solutions, which is first is the copper sulfate solution, which is a true solution, and a solution of water and milk, which is colloidal solution. If we, with the help of torch, if we directed the light through the copper sulfate solution, here copper sulfate solution is a true solution, due to which the path is invisible in the copper sulfate solution, while the light is directed through the copper sulfate solution is completely invisible. After that, it will passes through the emulsion, it means the solution of water and milk, and the path become visible. Because this solution is a colloidal solution, the particles, the light is scattered in it and the path become visible. Tyndall effect can also be observed when sunlight passes a dense forest. If a sunlight is passing from the dense forest, we can see there a Tyndall effect in the forest. Fog contain tiny droplets of water. It means in that forest, the fog contain a very tiny droplets which act as a particles of colloids dispersed in air. It means those tiny particles are present in the air. It means those tiny particles are dispersed in the air, due to which the scattering of light takes place by scattered with those droplets. Now moving to the next, here is the properties of colloids. Colloids is a heterogeneous mixture, as we studied yesterday. The size of particles of colloid is too small to be individually seen by the naked eyes. It means the size of the particles of colloidal solution are too small, which cannot be seen by the naked eyes. Colloids are big enough to scatter a beam of light. It means the colloids solution, in colloidal solution, the colloids particle are big enough to scatter a beam of light, due to which the path become visible. They do not settle down when left undisturbed, that is, a colloid is quite stable. It means, like in suspension, if we put it for a few time, or we can see that the particles of suspension which are suspended in the solution, they settle down at the bottom of the container of flask. But in case of the colloidal solution, if we left it undisturbed, the colloidal particle do not settle down in the bottom of the container or flask or vessel. So we can say that a colloid is quite stable. They cannot separate it from the mixture by the process of filtration, due to the small size of the colloidal particle, but they have a large size in comparison of true solution. It means, but they have the very small size in comparison of suspension, so we can filter out the solute and the solvent from the suspension very easily. But due to the small size in comparison of suspension, we cannot separate out by the process of filtration. But a special technique of separation known as centrifugation can be used to separate the colloidal particle. But here we can use a very special technique which is known as centrifugation. We can use this technique to separate the colloidal particles. Now here is a comparison of true solution colloids and suspension. In the very first row there is a property, and in the other third rows there is a true solution colloids and suspension. The very first is nature. The nature of true solution is homogeneous, whereas the nature of colloids and suspension are heterogeneous. Particle size, true solution have particle size less than 10 raised to the power minus 9 meter, whereas the suspension particle size has more than 10 raised to the power minus 7 meter, whereas the particle size of colloids are stabilized in between true solution and the suspension. It means they have a size in between 10 raised to the power minus 9 meter to 10 raised to the power minus 7 meter. Appearance, the true solution, because there is a complete solubility in the true solution, it becomes clear and transparent. Colloids, due to the small size of the colloidal particles in comparison of suspension, they are generally transparent, but we cannot say that they are completely clear. Whereas the suspension is opaque. Opaque is that state in which we cannot see from them. Filterability through filter paper, the true solution is completely filtered out from the filter paper. Colloids are also, but suspension cannot filter out through filter paper completely. Settling of particles in true solution, they do not settle. Colloids, they settle only by the process of centrifugation, while in suspension they settle down under gravity. Visibility, the true solution is don't show any kind of visibility because of their small size particles, whereas colloids we can see them under ultra microscope. And in suspension, because they do not dissolve at all in the solvent, we can generally see by the eyes. If we are talking about the Tyndall effect, due to the true solution of small size particles, the Tyndall effect do not show at all. Whereas in colloids and suspension, the Tyndall effect we can observe because they have enough large size to scatter a beam of light for showing a path visible and shows Tyndall effect. And this is all about for today's. On next turn we will discuss the further topics.